Welcome, Hornets, and thank you for joining me tonight. Today, we're going to be taking a look at what is called the polar form of a complex number. Now, we've already taken a look at what a complex number is in our rectangular plane. This is the imaginary plane where the y-axis is now the I value or the imaginary number, and the x-axis is our real number. And we've seen that we can plot points such as 3 plus 4i. And we can go ahead and we can plot that on the graph by locating 3 along the real axis and then going up 4 along the imaginary axis. And locating that point is very easy, and we label it at 3 plus 4i. But what we're now going to want to do is see something called the complex number in polar form. Now, please be aware, this is not a polar point. We are not talking about polar coordinates. We are actually just talking about the imaginary numbers written in terms of sine and cosine. And the way it works is we have r cosine theta plus I sine ri sine theta. Let me go ahead and put my I behind the sine theta. R sine theta I, just so it resembles this. Now, we often will factor out the r, leaving us with the cosine of theta plus I sine theta. And you'll notice I've moved the I back in front of sine. This will help us to remember because we refer to this as r c I s theta. Now, sometimes the theta will be in the parenthesis, sometimes it might be out of the parenthesis, depending upon the textbook that you're working with or the form that you're working with. Long time ago, we would even use things as an r angle theta. All right, so just be aware that depending upon the textbook you're using, they may give a slightly different view, but it is still considered polar form of a complex number. And the way we locate polar form is by recognizing that r is identified in terms of our x and y. So we have a 3 and a 4 here. And this then becomes the Pythagorean theorem, 3 squared plus 4 squared. And as a result, we would have the square root of 9 plus 16, and we get r equal to 5. That's the square root of 25, which gives me 5. Now, the theta is found by working with the position and our tangent. So if we are looking at theta is equal to the arctangent of the y value, 4, divided by 3. Notice that it is in the first quadrant, and when we use our calculator in terms of degrees or radians, sorry for leaving you there, we're just going to need to make sure that we have the appropriate mode. So let's go ahead and do this in degree mode. So I've now converted my calculator into degree mode, and I am working with the arctangent of 4 divided by 3. And I hit enter. And I get approximately theta equaling approximately 53.1301 degrees. Now this isn't exact, thus the approximate dot over the equal sign. As a result, in polar form, our 3 plus 4i in rectangular form becomes 5 cis 53.1301 degrees. I'm just going to go ahead and put parentheses around my values just so that I can see them clearly. Once again, this is what we refer to as polar form versus rectangular form. And that's what we're trying to do. So we can take any angle and we can work with it. So let's take another one and let's find what is negative 5 plus 12i. In our rectangular form, we're going to have negative 5 over here somewhere. We're going to put positive 12 up there, and I'm going to call it negative 5 plus 12i. Now, when we go and we put it into our polar form, we need to now figure out r first. R is going to be the square root of 5 squared, this negative 5, the quantity squared, plus 12 squared. This is giving me the square root of 25 plus 144, and this gives me the square root of 169, which we know is 13. So our r is 13. Now, this value is called the modulus, just in case you were curious. And our argument in this problem is going to be our theta. Okay? So we have the modulus, and we have the theta is the argument. So let's go ahead and find our argument. The argument is going to therefore be the cosine, the arc tangent of 12 divided by negative 5. And we already know that because it's a negative arctangent, it's going to give us the opposite of our reference angle. And we're going to have to project it into our second quadrant by simply adding pi. So it's going to give us this value here, negative theta prime, and we're going to find our actual theta by adding 180 degrees to it, since I am in degree mode. So here we go. We're going to just go ahead and put our arctangent, second function tangent, of negative 12 divided by 5. Enter. We now add 180 degrees, and we get theta equaling 112.6198 degrees. This gives us 12 cis 112.6198 degrees. Once again, I'm just going to put parentheses around things so I can see them clearly. Now, in order for us to convert back from our cis form into our rectangular, it's actually very, very easy to do. All we do is take 12 times the cosine of this 112.6198 degrees. And you'll notice what I'm going to do is I'm going to store this in my calculator exactly as I have it. Now when I do 12 times the cosine of this angle, I get negative 4.6153, and then I'm going to go ahead and use my plus I sine. So we have our, whoops, that's supposed to be 13. That's an error there. Sorry about that. I put a 12. It's supposed to be a 13 cis. And you'll notice that's why I didn't get negative 5, but I should now get negative 5. 13 cosine of that angle. You'll notice there's the negative 5 that I was expecting. If you don't go back to the same value, double check your work. It's important. And now I'm going to go ahead and I'm going to put in the 13 sine of this alpha A. And you'll notice I get that 12. So I have 12i. So you should be able to go back and forth between your polar form and your rectangular form by simply applying the formula that's been given. In this case, 13 cosine plus 13 sine of this 112.6198 degrees times I. And this will immediately bring us back. So this is how we change back and forth between rectangular and polar form. I hope this has helped. Please let me know if you have any questions or concerns. And if you found this to be useful, please remember to click like. Thank you very much. Take care, be safe, and I hope everybody has a very good evening. Remember, it's easy to be mean, so try to be nice to each other. It's the only way we can change the world. Bye-bye all. Cheers.